Step 5. Defining custom data types. In the last lesson, we added the ability to collect the raised amount in the crowdfunding campaign. However, as we said, right now, anyone is able to claim the funds and we can support multiple campaigns. In this lesson, we will begin to fix this by introducing custom data types. And in the next and final lesson, we will code our validation logic. Let's begin. As you remember, we use this to define a campaign. So far, we have just used basic primitive types in our contracts, but as soon as the logic in our contract grows, we will want to define our own types. Luckily for us, this is easy to do. We will define a campaign data type that will hold any relevant information to a specific crowdfunding campaign, such as the campaign deadline, the campaign target, the campaign collection deadline, and the campaign owner. To define that data type, it will look something like this. We go to our code, and then here, let's define data campaign collection deadline, campaign owner, and we close it. In Haskell, we can define a new data type just as we have the int data type to handle numbers. We can have a campaign data type to handle multiple campaigns. We just define it using the data keyword as it's used here. We see that its value constructor as a name campaign takes 4 pieces of information. The slot for the campaign deadline, target, which is an amount of ADA we want to be the goal for the crowdfunding campaign, the collection deadline, which is the time at the end the owner of the campaign should be able to collect the funds, and the campaign owners, the public key. There is one more thing missing in our type declaration, and that is the deriving keyword. For the deriving keyword to make sense, we have to know about type classes. There is a lot to explain about them, but we just need to know that Haskell knows how to treat values of some type because it has a type class instance that states how a value of a specific type can be used, what operation supports, etc. We want our data type to have some useful behaviors. Mainly, it should be serializable to and from JSON encoding, and that's why we put the to JSON and from JSON there. Also, we want to use the toSchema type class allows our data type to have a representation as an API resource. More precisely, it defines the schema for our data type to be used in the specification of an API. Currently, we need to add this so that the playground can interact with our data type. Now, what about the generic instance? This one involves more magic. It allows the Haskell compiler to automatically add missing boilerplate code needed for the data type to work correctly under certain conditions. In this case, we use it so that we can lift or transform our data type to work with Plutus, the on-chain side of the code. Now, after defining our data, we need to add a way to convert that to on-chain code. That is, in the Plutus programming language. The way to do this is to use the make-lift function from the language Plutus TX module. So, like this. More like this here. Notice how our data type is prefixed with double quotes. With this, we can all use our campaign data type in the Plutus code. Now we'll use the campaign action. We will use a data type to represent what actions are available within the validation logic. For example, our contract should support the action of collecting the funds raised in the campaign, which should only be performed by the campaign owner, and also an action to refund the user contribution to the campaign that should only be made by someone who actually contributed to the campaign. This new data type will be used as a redeemer script so that we know which action to validate in the validator script of the contract. We will call this new data type campaign action, and we will define it like this. Campaign action. Campaign action is the collect or refund. Notice how the structure of this definition is a little bit different. There is a pipe character in there that in the previous declaration wasn't. These type of definitions are called sum types, and they are characterized by having more than one value constructor on the right side of the equal sign. That means that to create a value of type campaign action, we can use either the collect value or the refund cost or the refund value, which also accept arguments. We already saw that the deriving section refers to. So let's move along and also allow the on-chain usage of our data type with the make lift function. There you go. We have the make lift there. Both the campaign and campaign action data types are all we need for our crowdfunding content. Now we will use that data type in our code. So with the campaign data type, we'll have several campaigns available. The first thing we should do is pass a campaign to the validator script. So if we go to the validator script, like so, we can have a campaign here. And now, here, and then we will have the validator script going to be apply script validator ledger lifted campaign. And then where validator is equals to this right here, and also now our lambda expression needs to know about the campaign Let's look carefully. There are 7 changes here. We take a campaign argument of type campaign. We bind the validator script to a validator local variable in the where clause, and we use the apply script function from the ledger module on the validator to pass to it the campaign argument in its lifted form. Notice how the validator lambda expression now not only takes 3 arguments as before, but 4. These are campaign value, the one that is passed using the apply script function, the data script data of type pub key, the redeemer script, and the current pending transaction. Because the definition of validator script just changed, we need to update all the references that use this expression. Let's begin by updating the contract address definition. The contract address will take a campaign now. A campaign script campaign. In order to compute the address of this validator script, we need to first give it the value of campaign so it knows which campaign it will refer to. Now let's go to the contribute action. Contribute action. Now we will take also a campaign, because you need to know to which campaign you are contributing. We'll need as a parameter campaign, and now let's calculate an address here. It's going to be the contract address of the campaign like this. Let's compile. Let's see if because it's watch contract doesn't, it's not needed anymore. Actually, it shouldn't be here. And now they're okay. That's perfect. Now for the contract address, contribute. Now here the refund trigger will also need to know the address which to refund, and the refund handler will take the campaign ledger. So we did the same thing. We changed the action so that in addition to receive the add amount to contribute, we will also accept the campaign value to know to which campaign the user is contributing to. Note that the refund trigger also makes reference to the contract address. On the other hand, refund handler referenced the myvalidator script, which now takes the campaign argument. So besides to the transaction ID, we pass to it the campaign value. Due to these changes, the way to register both the refund trigger and the refund handler will change. So we need to change their definition. Now, refund trigger, here, refund trigger. Now, refund trigger now looks like this and requires an address. I'm going to return a tree. And then receives an address here. And instead of using this one, it's going to use the one we're sending. And now that the refund trigger has it, we need to also modify the refund handler. Refund handler is here. The refund handler is here. The same way, now it takes a campaign, the transaction ID, takes a campaign as part of the parameter, and now the validator script, create a local validator script, variable equals to my validator script of the campaign I'm sending, and this one becomes the validator script right there. Now we take the campaign as the first argument, and in the let block we define a value validator script, which is just my validator expression applied to the given campaign value. We use this value in the collect from script transaction function call. Now the collect funds trigger and collect funds handler will also need to be updated, since they also refer to the contract address validator script. Let's update the trigger. So collect funds trigger, there you go. Collect funds trigger, it has a campaign, it has a parameter here, and now here contract address, we use the contract address of the campaign, and then we now accept a type of value campaign as argument, and we use it in our has funds trigger definition to pass it to the contract address expression that needs it to compute the contract address. For the collect funds handler, we have changed its link. So collect funds handler now will also need to be a campaign, and it takes a campaign equals event handler logman redeemer script, and it's going to be same case, and validator script equals campaign. Collect from script branch, here it will change to the validator script made here. Now it takes an argument, and in the let block we use it to pass to the my validator script expression. We bind the result to the validator script and use that value in the collect from script function call. Okay, the last thing we have to update is the schedule collection action, as it registers the collect funds trigger to the handler. So in schedule collection here, we need to add a campaign, now it becomes a parameter, and now collect funds trigger will receive a campaign, and also the collect funds handler will receive a campaign. This campaign is those. Let's make sure our code compiles. There you go. Now, if we use the schedule collection event, see how the data type campaign appears here. And we just need to fill the data. And also, if we use the contribute action, see how we are sending again the campaign data that it's required. So for example, if we go to the campaign deadline 30, our goal is 28 days, pub key gets locked to slot 40, pub key here, I will use this pub key. As I said, your interface should be nicer than this pub key. And the same data should be entered here because it should represent the same campaign. Now let's do a contribution here. 10 ADA. Oh, this is what I want. Let's say Bob is going to contribute to the deadline 30. To the goal is 20. The Bob Kim, that one. That's one, and it's going to contribute 15 ADA. And let's add Carol, and she's also going to contribute to the same campaign. ADA, well, 15 ADA, and I'm going to just to give them more money. I'm going to give them 20 and 20. And at this point, we have correctly introduced the campaign data type. If you interact with the Plutus playground and are the contribute or the schedule collection action, you will see that now we have to provide values, as we did here, for the campaign we wish to contribute to. Now let's add our campaign action data type in the code. As we said earlier, this type will be the type of our redeemer script, so we will update the code involving the creation of the redeemer script. Let's begin with collect funds handler right now. Let's go this, go to the here, and the collect funds handler redeemer script. Currently we are using the redeemer script like this. We now want to use a value of type campaign action, so we can create such value either by using the collect or refund data constructors. Since we're in the collect refunds handler, it makes sense to use the collect data constructor like this. So we have the redeemer, and we have, instead of unit, we will use collect. That comes from the campaign action data type that we defined here. Okay? Over here. New things are happening here. In order to collect the funds from the campaign, we signal this intent specifying the collect data constructor. So we pass it down to the redeemer script constructor to construct the campaign action value we want to use as a redeemer script. Now, let's update the refund handler expression, since we are also creating a redeemer script with the unit value like this. So refund handler here, now instead of unit, we'll use refund. There is one last thing to change, and that's our validator lambda expression in the validator script. Now the type of the redeemer script is not unit. So now let's go and change our validator script. Here, receive the campaign, and now the redeemer script is of type campaign action. Now let's increase the readability of here. Now redeemer script, let's call them action, since it is more intuitive of what it means in this context. And now let's change the data script to be the contributor, since that's what it represents currently. And we should stop ignoring the pending transaction here, and let's give it a name, PTX, pending transaction. Now let's update our validator logic. Instead of being always valid, now it's only going to be valid case action, this action right here, of collect or refund. We will use the case expression to pattern match on the action value. So we will perform the collection logic when this is about the collect case and the refund logic when it's about the refund case. Okay, so in this lesson we implemented our own custom data types to support multiple campaigns. We also lay down the beginning of a true validation in the validator script. On the next lesson we will finish our crowdfunding campaign. Stay tuned. So let's see if everything is compiling. There you go.